Hello, welcome. This is a video from Unit 5 on graphing quadratics from factor form in preparation for our semester 1 final. This question asks us to find the indicated key features of a specific graph, and the first thing that it asks about is the domain. And the important thing to keep in mind about the domain is that it's all of the x values in this graph. And we're going to use interval notation, all of the x values. We're going to use interval notation to show what are the x values here. Because we're talking about the x values, it is important also to keep in mind that if your graph goes to the edge of the graph, we're going to assume that it continues. So there's an arrow there. And here as well. And so if I project all of these x values onto the x-axis, just all of them go up here. On this right end, there's an arrow, which true is going down. It's also going to the right. And so I'm going to put a right arrow here. And the same thing is over on this side. On the left, there's a left arrow. And then it's all of those values there in between as well. So the fact that this has an arrow both on the right and on the left means how far to the left does this go? Well, it's going to continue to go to the left in that direction indefinitely, and so we're going to say it's negative infinity on the left, and on the right is positive infinity. And those would be all of the x values. Now, the range, likewise, are the y values, all of the y values. And the y values are up and down, as opposed to the x values, which are side to side, left to right. And so you have to list the minimum value first. So this time, I'm going to just kind of move everything off to the side. At the top here is a vertex. That's that point, -1, -4. It's -1 in x, moves to the left 1, and then down 1, 2, 3, 4. And so I'm just going off to the right just a little bit here. Because the y-axis is there, it's kind of busy. So I'm just going to move it to the right where it's easier to read. The top value there at this point, y is equal to -4. And then all of these values come over here just so we can kind of read them all together. And at the bottom is an arrow continues on the way down. And the least values, when you're listing them, the least values are on the bottom for y, and the greatest are up. They're on the top. And since we're listing interval notation, the least values go to the left. Since on the bottom it goes down, the least value here is negative infinity. But you have to think that here, this meant left, and this meant right, that it goes all the way to the left and all the way to the right. Here, this means down, and it goes up only as far as y equal to -4. And so here we would put a -4, and then we would put a bracket to show that it can be equal to that value. When you're in interval notation, you either have a parenthesis or a bracket. We use parentheses to show it cannot be equal, but goes to that, approaches that value. But we use a bracket to show that it can be equal. All right. Now, the direction of opening. Well, this opens down. I mean, if you're just reading it from a graph, you might find this helpful. That here it opens up, or it opens down. And this is what it would look like if it opens down. This is what it looks like if it opens up. This obviously opens down. So we would just put down. It's quite simple. That's what they're asking. Direction of opening means that it opens either up or down. Something to keep in mind is that if you're looking at this, if you're looking at the equation, this means that a is less than 0, which means it's negative, and here a is greater than 0, which means it is positive. So if it's positive, it's facing up. If it's negative, it's facing down. And in this case, we're just seeing the graphs. We're not seeing the equation. But if we did, in this case, a would be negative. So it could be something like f of x equals negative x squared, and then whatever else it has on there. But the leading coefficient would be negative. Okay, maximum or minimum. It's either one or the other. And in this case, there is a highest point, which means there's a maximum. Minimum means there could be a lowest point. But the fact that this goes down and continues to go down, there's no lowest point. Whatever point you put down there, it continues to go down. And so you can say that minimum, the maximum point occurs at that vertex, which is -1, 4, which is not just the maximum, but is, like I said, it's also called the vertex, which is either going to be the maximum point or the minimum point of a parabola. The end behavior, x approaches negative infinity, means as x goes to the left, as we go to the left, so this is to the left, what's happening? It's asking this blank here in y says, what's y doing as we go to the left? And we see that as we move to the left, y is going down. And so we would say then y approaches, that's how we would read this, is approaches. Y approaches negative infinity. And then x approaches positive infinity. This just means what happens on the right. So to the right, as x goes to the right, or as x approaches positive infinity, to the right. That's what x approaching infinity means. What does y do? Well, as we go to the right, y is also going down. And so over here it's also going to be negative infinity. And that's it for this. Again, practice, study, do your homework. If you have questions, please ask. You got this.